started telling a lot of my data science colleagues and friends that I was starting to do a lot of work in real estate, the first response I got was just a blanket, but why? And that a lot of that's coming from the fact that as a data scientist, when you think about geospatial analysis or you think about property analysis, the immediate response is like, well, that's really boring and there's no real data that's accessible to you and everything is just a population density estimate and that's all it is. And there's a lot of reasons for that I think are starting to change coming up into the next couple of years. But the core things are like when you start working with this kind of data, it's really difficult to get access to anything. All the data sets are really scattered. There are a ton of data providers who have started coming up to try to help solve this problem, but it's an enormous problem to try to solve. And what we kind of see is a lot of fracturing within the space. So you have some data providers who are very specifically focused and we're going to get exactly this kind of data and that's going to be our specialty and that's going to be our UVP. And then you have some other types of data providers where they're more generalized and they're kind of saying, we're going to work with whatever clients want to start working with us and whatever clients want to start getting into data and property. And then they just kind of try to collect whatever data is going to be required for whatever use case that that client's going to be working on. Regardless of the approach you're taking, the kind of core problems that you're trying to actually solve in that space are the data is really scattered. It's typically really hard to get. Because it's either you're going to have to build a lot of web scrapers to get access to the information. Potentially the information is centralized somewhere, but it's not really digitalized very well. We see that a lot with like development applications for doing construction on buildings. These are very centralized data sources because the governments have to actually keep track of this. And if you're going to do any work, you do have to do this application and apply to do this kind of work. But then when you start working with that data, in order to get any real value out of it, if you're going to be doing any kind of large scale project, you have to have really strong natural language processing practitioners that are actually working with that data. And that's its own very kind of specific and difficult discipline within data science itself. So you have to be able to kind of get that information. You have to then kind of know what you actually want to do with it in the property space. And then you also have to have this team of experts in this really difficult field of data science. The other kind of side of this is the data is not open source, it's not accessible, and it becomes really expensive at that point. So if you're kind of an individual, if you're in the data science field and you're kind of interested about getting into property analytics or geospatial analytics, you immediately hit these massive barriers that you can't possibly surmount yourself. Like there's no data scientist out there that I know of at least who's going to pay $10,000 themselves to get access to like a point of interest data set so that they can start experimenting with geospatial analysis. It's just not going to happen. So these are all kind of the issues that as a solo data scientist, you're going to face trying to get into this industry. Like you have to learn web scraping, which basically means you have to learn web development so that you can understand how you're going to be picking apart these various websites, or you have to pay someone to go get that information, which is going to be very expensive. Once you get the information, then you have to have this entire other groupings of skill sets. So if you want to be working with unstructured data like the development applications, you have to then learn natural language processing, which in and of itself is like a multi-year discipline that you have to study and familiarize yourself with enough so that you can actually do anything interesting. Then you also have to start going into all of the geospatial analytics processes and learning all of these structures. And that's also that's a very difficult place to operate as well, because the requirements for doing this kind of processing, or at least the focus of the data science community in this area, is a lot more geared towards breadth than depth. So all these libraries are built to optimize use cases that look more like Google Earth than like analyzing a specific city, even though you can never really get detailed information on everything in the planet. So all these libraries are built so that they can process tens of millions of building polygons at a time and do it really efficiently and do it very, very quickly, which takes a lot of effort to try to actually configure that platform within any web development system or within your own programming environment. And then it's not something that you can really use very easily, because like if you're a data scientist in Seattle and you're kind of interested in doing some project with, like, let's say local Seattle government, and you want to kind of look at trends in where different parts of the population have been moving, like what's potentially becoming too expensive and maybe needs some level of price control or rent control. You have to wade through this enormous gulf of technology that's built to do global sized analysis when all you really want to do is look at 40 neighborhoods within Seattle. And that's, it just, again, an immediate barrier to actually being able to do any kind of work with it. So you have these systems that are built to handle gigabytes and hundreds of gigabytes of data, and you really only want to put a couple hundred megabytes of data into it because that's all the data that there is around Seattle. So from an individual data scientist perspective, this is why a lot of people kind of don't get into the space, because there are these massive barriers. And then there's not really a clear ROI on spending the effort in building those skill sets, because there's not a massive market for data scientists in property. As opposed to like if you're doing like neural network based time series analysis, that's incredibly useful for a lot of IoT applications and a lot of banking systems and trading algorithms. So if you spend the time to learn those disciplines, you have an enormous amount of opportunity that you can then go into. So if you're sitting there in your home as a data scientist and you're wondering, what should I be studying so that I can build the skill sets that are going to make me employable, you're not going to go into the property direction, because why would you? There's an enormous barrier to entry, and then there's not really a whole lot of opportunity outside of that. And like data scientists don't really like doing the whole data gathering thing. We kind of view that as like dirty work that we don't want to get involved with. We want to be focused on like the pristine, pretty algorithms and everything, which I kind of disagree with, but we'll get into that.
So that impacts innovation, right? Because like standing from the property side, there's all these use cases and business problems that data science and analytics and advanced analytics really, you know, if the more we know, the more competitive advantage we have and the bigger the moat we can build. And there's so many applications of this for our real estate businesses and the real estate businesses in the future. So the innovation is getting hit because of these barriers to entry.
Yeah, exactly. And so from a company perspective as well, it's incredibly difficult for a property company to build an internal analytics practice. So just to recap, kind of the core issues that we're seeing as an individual data scientist, the data is really scattered. It's really difficult to work with because of all the different formats that it comes in. It's really expensive to access. And there's also a lot of focus on breadth instead of depth. So you can't do a whole lot of very interesting analysis in the first place. When you translate these kind of individual problems up to a business scale, so let's say we had our own property company and we're very established in the market, but we want to start building this analytics practice. We basically have to start entirely from scratch. So the first thing we have to do is we actually have to hire a data science team. And that is an incredibly expensive proposition. And we're also going to hit an issue where it's very hard to find data scientists that are really skilled in general, but you don't really need just a data scientist. You need someone who has this really broad set of skills when you're first starting this department, because they need to be able to understand the web scraping and how to get the data. They need to be able to understand what to do with that web scrape data. Then, like, how do you clean it? They need to have some level of natural processing exposure and skills, or natural language processing exposure and skill, so that they can deal with like the really high volume of unstructured text data within this field. And then they also have to be able to put things into production, build dashboards, because you're building a service in the company from scratch. So it's really expensive and difficult to find the right team. Once you find the right team, you're probably going to have to buy a lot of data, and that's also incredibly expensive. And this is all just the work you have to do to try to get to the point where you can prove the potential value of having a data analytics practice. So there's no guarantee that once you actually put in all of this investment that you're going to get something that's good and useful out of it. Because because of all these barriers, like no one's really been able to really robustly prove the value of analytics within the industry, because it's really hard just to get started. And then so let's say now you have that data science team up and running, and you've bought a couple of data sets and things are starting to come together like pretty nicely. So everything has gone fantastically for up till now. Then you have to start implementing a massive amount of change management within your own organization. And you have to do it in a way where you can get all these stakeholders from all these different parts of your business together to start working with this tech innovation team And there's going to be a lot of false starts within this. So there's going to be a lot of ideas that the tech team starts chasing that just immediately fall down on their face and don't go anywhere. And then you have to spend a lot of effort managing all the stakeholders to be like, hey, it's okay that things are failing. We're trying, like we're going to keep pushing this forward. And all this time, you're investing a huge amount of both just capital and also just like people management resources into building this practice. So because of all these barriers to the individual data scientists, there's a real lack of understanding of how to actually do this kind of analysis. And there's no real consolidation of a lot of the information and ideas. And then that leads to it being very difficult as a company to build any kind of legitimate practice. So you get into this kind of valley of despair for analytics in property because it's just so hard to build up any kind of momentum to get over that initial hump of like, this is difficult and expensive to do. And then, you don't even know if over this hump, if you're just going to go straight back down into a valley, or you're actually going to kind of start plateauing over into like nice green fields of greatness.
Mm. Yeah, it takes a huge commitment. I know from the last 2.5 years we've been working on it. It takes a huge level of commitment and linking together the aha moments for the stakeholders, because the ROI is exactly that. An insight is great, but until we take the action, there is actually no ROI to the business. So it's about working with stakeholders, iterating, all that stuff. And absolutely, we've had wins. And it's really taken a lot of time and investment by the businesses. There's not very many property companies in the world that I know that, one, are willing to move past the prototype phase to actually fund the operational version, because that's very different from let's try a few things, right?
Yeah.
Let's try a few things, let's get some aha moments, to then operationalize is a whole nother world. And we have to keep innovating constantly. So it's something, we've been working on. We definitely have some wins. And what I would say is, it's hard. This is not an easy thing to build internally.
Yeah, absolutely. And even externally, you have to have such a different approach to data science in general to get a lot of this up off the ground, because these algorithms were all built for massive amounts of structured data. Like there aren't really that many algorithms that lend themselves very nicely to really messy and very disparate types of data that you're going to see in property that then become the really important parts of actually like assessing a neighborhood or a building. But this all leads to a massive opportunity that's coming up in the next couple of years for all these property companies and tech companies operating in the space and data providers to really change how this entire landscape works. So that's going to require a lot of consolidation of how data is actually collected and how it's served. It's going to require kind of pretty significant investments into refining some of the kind of existing technologies into something that's easier to get started with for the data scientists themselves. And if you can kind of start doing these things, then you're going to start seeing this enormous change and enormous evolution in how these data sets are actually ingested and used and understood and analyzed within these companies. And you're also going to see a real big shift in the data science community, I think, away from there is already a little bit of a trend away from just kind of like a machine learning algorithm is going to predict a thing and then give you the answer into these more kind of decision intelligence structures. But that's really like property analytics has to rely almost entirely on decision intelligence structures, because there's so many human relationships and there's so many different nuances with all these different buildings that you're not really going to feasibly be able to integrate into any kind of specific algorithm. So it's all about kind of trading off advantages and disadvantages of a building. So that lends itself very well to certain types of unstructured or certain types of unsupervised algorithms. And we're going to see a huge like kind of influx of ideas around how to adapt those types of algorithms into the space, especially once we start making the data sources more approachable and the technology ecosystems more approachable and easier to get started with. So the real big focus is just how do we get these enormous barriers to entry reduced enough so that individuals in the data science community and the property community can actually start approaching these problems and playing around and experimenting, because you're not really going to see any significant changes in the industry until you start opening it up so that people can come in and easily try new ideas.
Yeah, I love that. And I love the reduction of friction early so that innovation can happen, right? Like if we can play around, we don't hit paywalls, we don't hit a whole bunch of things where we need to go do business cases to the board, we can actually play, we can see the ROI, we can look at it, innovate, take the actual on the ground outputs or outcomes and have that as the input into the business case. All of a sudden, it's actually true versus what we think is true before we even try, if that makes sense.
Yeah, exactly. And it's both kind of sides of the table are a little bit at fault for kind of stagnating the industry a little bit. Because the data science community has done itself no favors in insisting that price prediction is the way to approach property analytics. And understandably, the property industry has been a little bit resistant to that because the pricing models are actually so complex and integrate so many different ideas that machine learning algorithms they're just not really going to get it that right. And then if you're focusing on the massive, premier A-grade buildings in every city, the property companies they know everything about those buildings already. So you're not going to build a model that kind of teaches them anything new if it's just trying to predict the price. Mm. So one of the really important things that's going to have to happen, and this can't happen until these barriers are removed, is there has to be a lot more of a open dialogue between the analytics providers and the data scientists and the property managers and the acquisitions teams and the research teams, so that they can actually trade these ideas back and forth. Because when I started working with you, I came in with some preconceived notions of how property analytics should be done because I know data science and therefore I know the right answer. And it was a massive learning curve for me of, a lot of these ideas that we kind of hold near and dear to our hearts as data scientists just don't translate over into the property industry. You can't operate within that boundary of data science that we kind of erect to protect ourselves and our ideas in a lot of ways. You have to really take a lot of chances and use algorithms in ways that they maybe weren't intended to be used, but have certain characteristics so you can kind of skirt around the kind of traditional approach to analytics. And if the data scientists aren't doing that, then there's not really ever going to be kind of this real utilization of all this really rich data around all these buildings.
Yeah, I see that. Well, this has been great. Thanks so much. And I can absolutely see what you're talking about in terms of the opportunity, because reducing the friction, allowing the innovation to flourish. We don't know what we don't know until we get in there, which you've been in there for a couple of years. And so I know you're seeing a whole bunch of stuff, but it's a very exciting time.
Absolutely. Yeah. I'm very excited. It's great.
Cool. Well, onwards, and we'll talk more in our next discussion.
Great. Thanks, Joe.
Thank you.